We really appreciate you being here, and on behalf of the Sacramento Clean Cities Coalition and also the Long Beach and East Bay Clean City Coalitions, we're very happy to be able to present this in a series of our Tech and Spec webinars. I would like to thank our sponsors for making it possible for our coalition to continue to operate and make it possible for us to continue to have these webinars. And I just wanted to, and with that, I will now toss it to our pre-featured speaker, who is Annalloyd Thompson, who is the Vice President and General Manager of the Natural Gas Vehicle Institute. And Annalloyd's going to walk us through a very interesting and informative presentation for technician training and certification on natural gas vehicle technology. So with that, Annalloyd, I'm going to stop sharing my screen and turn it over to you.
Very good. Thank you, Tim. Thank you for inviting us to present today. We're going to cover a lot of information in a pretty short time period, so I appreciate everyone being here. I am Annalloyd Thompson, and today we're going to talk a little bit about all things CNG fuel system inspections. For those of you who are not familiar with our company, NGVi, we've been in business since 1989. August was our 31st anniversary of being in business. We specialize in nothing but natural gas vehicle and fueling training and consulting. We're the only ASE accredited training provider in the entire alternative fuels industry. And many technicians obviously are familiar with ASE because many of you are ASE certified. This is a different type of accreditation. Our accreditation as a training provider means that we have submitted everything involved in our creation of training, our development of curriculum, our hiring and onboarding of trainers, our record keeping, everything to the ASE case process. It's been peer reviewed and then it's been accredited. Accreditation is good for 5 years. We're in our second 5-year period, so we're pretty proud of that. Since we were formed in 1989, we've trained more than 22,000 technicians, engineers, other technical professionals, and we train the entire natural gas for transportation user chain, and I'll show you a little bit more information about that in a moment. We have unique courses that are designed specifically for each audience. So you can see here, this is a snapshot of one of our website pages. We have training courses for drivers. We have unique training courses for service technicians or supervisors or managers who are working in either a natural gas fleet or a dealership. We have a specific training course for fuel system inspectors, which is of course what we're going to talk about today. We also have a training course for fuel system manufacturers, helps make sure that their installers understand the installation code and why they're being asked to do what they do. And then you can see on the bottom, we have another variety of courses. We have courses for fueling station designers or for maintenance technicians on fueling stations. And then lastly, we also cover off on the fire marshal, code official, firefighter, first responder realm. You'll notice on the upper right-hand columns that we deliver our training courses 3 different ways. We do live in-person training. We offer live virtual training in a virtual classroom, not a webinar platform, but a virtual classroom. And then we have on-demand e-learning. So as you look down that list, that's a list of all the courses that we offer and the types of training that we offer and the various ways that we offer it. So we try to be as flexible as possible and offer training in as many different delivery modes as customers require it. This slide depicts the breadth and depth of the companies, the types of companies and organizations who are our customers. So you see trucking fleets there like UPS and Frito-Lay and FedEx. You see refuse fleets like Waste Management and Republic Services. You see transit agencies. Sacramento RT is one of our clients, Miami-Dade. We have a wide variety of those. Vehicle leasing companies, and then a whole variety of manufacturers. Gillig is a school bus manufacturer, obviously. Volvo and Mack are truck manufacturers. So our customer base kind of includes the entire range of CNG industry folks. So let's get into the meat of today's topics. I know that you were coached on asking questions. I'm going to pause at the end of each of these sections, and one of my coworkers, Sabrina Dodd, is going to filter questions. She will either answer questions to you individually or she'll ask them of me at the appropriate pausing time. So we're going to start today by talking about CNG fuel system inspection requirements. And then we're going to move into the 4 different types of inspections and intervals. Many of you might not know there are 4 types of inspections and intervals, so we're going to talk about those. We're going to talk about the components that are required to be inspected. Then we're going to move into the inspector responsibilities and qualifications. And we're going to take a closer look at just one of those 4 types of inspections, and that is the detailed visual inspection. And then I'm going to show you some common inspection findings, and I'm going to talk to you a little bit about training and certification. So first, let's cover off a little bit on fuel system inspection requirements. In 1995, when natural gas vehicles started becoming more prolific in the market, US DOT created, as part of its manufacturing standard for cylinders, a regulation called FMVSS 304. And it basically required that cylinders be inspected every 3 years or 36,000 miles or after any accident or fire. In 2008, the natural gas vehicle industry recognized that just inspecting the cylinders was not adequate. And so the industry adopted a best practice of inspecting the entire high pressure CNG fuel system. The label that is required by DOT's FMVSS 304 reads, "This container should be visually inspected after a motor vehicle accident," just as I said, or fire, or every 36 months or 36,000 miles, whichever comes first. The word container there is interchangeable with the word cylinder. Many people call a CNG storage cylinder a tank. It's really not a tank. Tanks are for liquids, cylinders are for gases, but DOT also uses the word container interchangeably with the word cylinder. And you can see, indeed, this language has to be included on every label for every CNG cylinder that is manufactured in the United States. So, types of inspections. There are 4 types of inspections. There is a pre-service inspection that should be performed prior to placing the vehicle into service. It is a detailed visual inspection. It's not one of the more cursory inspections, and it should include a thorough inspection of all the high pressure components, including the cylinders. And it should be performed by a certified or qualified CNG fuel system inspector. Many of you may not know that for heavy duty fleets, there is a requirement that there be an inspection, a cursory visual inspection of the CNG fuel system, at least the visible components of it, before and after each trip. Just like all the other federal inspection requirements, this should be part of that inspection, and that inspection is to be performed by the vehicle driver. There is a general visual inspection that should be conducted anytime a vehicle is in the shop for any preventive maintenance or any service. It should be done by a trained vehicle technician. And again, it's not the detailed visual inspection that we're going to talk about. It's more about the visible components. So cylinder shields, fuel receptacles, that sort of thing. And then finally, the fourth type of inspection, which is the inspection that is referred to in DOT's FMVSS 304, is a very thorough inspection of every one of the high pressure components, including the cylinders. And we'll talk a little bit more about what that entails throughout this presentation. Now, let's talk about US DOT's intervals for a moment. For heavy duty vehicles, there is a little bit of a discrepancy. So DOT's requirement says every 3 years or 36,000 miles after any fire or accident. And FMVSS 304's or DOT has been petitioned by the natural gas vehicle industry to revise this standard for heavy duty vehicles, because heavy duty fuel system manufacturers believe that it is appropriate to perform an annual inspection of heavy duty fuel system. And the reason for this is for a big fleet like UPS, who runs a lot of miles on a heavy duty tractor, every 36,000 miles comes every 90 days, and that's pretty frequently. So there has been a petition issued to DOT, actually to NHTSA, to modify that inspection interval, but there has been no ruling yet. So right now, if you're a fleet operator and you're operating buses or trucks or anything in the heavy duty realm, you have to make a choice. And so here's our first poll question. Which CNG fuel system inspection interval would you choose, knowing what the regulation says and knowing what the manufacturers say? Which would you choose? All right, very good. 53% of you said you would choose the manufacturer's recommendation for an annual inspection. 21% of you said you would choose FMVSS 304's requirement or recommendation. 26% of you said you might do both, and none of you said you would do neither. So that's interesting. Again, it is your choice. And everybody makes their choices based on their own information and their own fleet. All right, we will move on. Next, we're going to talk about the components that are required to be inspected. So in the detailed visual inspected, every high pressure fuel system component must be inspected. Starting with the fuel receptacle that you see on the right-hand side of the drawing, moving through the secondary check valve. The entire defueling system is part of that high-pressure fuel system as well. All the fittings and the tubing and the lines. The cylinder shields and the mounting system, we'll talk about that further in this presentation. Cylinder valves, the PRDs, the tubing, the caps on the ends of the tubes, the fuel system isolation valve, the high pressure coalescing filter, the fuel system isolation solenoid valve, any mechanical pressure gauges, the fuel shutoff solenoid valve, the pressure regulator, and the labels. So a complete, thorough, detailed visual inspection includes all of these components. I want to talk for a little bit about the responsibilities and the necessary qualifications of a CNG fuel system inspector. I'm going to make two statements that I believe with all my heart after being in this industry for 31 years. The safety of every CNG fleet, no matter whether you're talking about the drivers, the technicians who will be working on the vehicles inside the shop, the customers, or the general public where those vehicles will be driven. Safety depends largely on the knowledge and the skill of the CNG fuel system inspector. I'm going to give you a second premise. The CNG fuel system components are manufactured and installed to extremely rigorous standards, far more rigorous than gasoline and diesel, because you're dealing with a high pressure fuel. And this means that CNG vehicles are extremely safe. But if a fleet fails to perform a fuel system inspection adequately, or does not have a properly trained fuel system inspector to be able to detect damage or unsafe operating conditions, then a worst case scenario looks catastrophic. And I'm going to show you what a worst case scenario could look like. This is a CNG fueling station in Bakersfield, California. And this is what happens when a cylinder ruptures in a vehicle. This is what happens to the station, and this is what happens to the tractor. Every major death-related or serious injury-related incident involving natural gas vehicles has occurred because of undetected damage. So I just can't stress how important it is to make sure that fuel system inspectors know what they're doing and are qualified to do it. Fuel system inspectors need two things. They need knowledge, and they need very high levels of knowledge, and they need skill. First of all, they need the very highest measurable knowledge levels about the function and the inspection requirements of every one of those components that we listed on the chart. And secondly, they need knowledge and measurable knowledge of the requirements of the installation code, which is NFPA 52, that applies to the particular vehicles that they are inspecting. And in addition to that, they need knowledge of CGAC 6.4, which is the generic inspection standard, and of course the manufacturer's guidelines. These are the three documents that guide everything that the fuel system inspector does. And in addition to that knowledge, I'm not going to read all of these to you, but the inspectors need a very high measurable level of skills to do everything from knowing how to prepare the vehicle for inspection, to how to locate and identify all the fuel system components, because as many of you know, if you're working on these vehicles, a PRD, one PRD on a vehicle does not look like the same PRD on another vehicle. It's not installed in the same place, etc. One of the most important skills is to know how to apply the knowledge from the codes and standards to the inspection process. And then you can read down the rest of this list for yourselves. Detecting and measuring and classifying cylinder damage, which is a whole special level of skill. What they need to do if they find cylinder damage to mitigate safety hazards, and then how to keep really good records so that the inspection is documented well. We talked about NFPA 52. NFPA 52 is the primary document that is used, that an inspector is going to use to guide the inspection. And it includes very specific requirements for the design and the construction of the fuel system, the permissible locations of components. You can't just put components anywhere. They have to go, there are permissible locations. What happens when cylinders expire? What happens if any components of the fuel system are installed inside a passenger compartment, including a trunk? What are the requirements to protect the cylinders? What's the positioning requirements and the ground clearances of cylinders? What are the requirements for mounting brackets? What's required for cylinders involved in fires? And a whole bunch more content that fuel system inspectors need to be familiar with and then be able to apply. So before we move into a look at actual fuel system inspection, answer this question for me. A CNG fuel system inspection is really just a leak check. True or false, or I don't know? Very good. Good audience. Good class. 93% said false. It is not just a leak check. So we're going to talk a little bit more about why that's true. So let's now look at the detailed visual inspection process. There is a preparation step, and I'm giving you the big picture, high level overview. You can't take these 5 slides and be adequately prepared to do a fuel system inspection, but I'm just going to give you the big picture overview. First of all, it's important to know the vehicle's history. Has it been in an accident? What were the results of the previous fuel system inspection, if there was one? You have to be able to assemble the correct tools and forms to perform the inspection, and if it's feasible, you want to be able to remove the cylinder shields, because you have to be able to inspect visually 360 degrees around every cylinder. And you need to be able to clean the cylinders with a shop towel so that you can see cuts, scratches, gouges, etc. Then you begin with the fuel receptacle. You're looking at the receptacles. This slide shows you an agility fuel system, fuel management module that includes the fuel receptacles. You're looking for any damage to the receptacles. Damage like, are they loose? Damage or like, is there any evidence of Brunelling, which is caused by the continuous insertion of the nozzle, the fuel nozzle over the receptacle, and not doing that perhaps in a proper way, verifying that the O-ring is present and undamaged, and then there is a leak check of every component, so you want to leak check the receptacle and the connections. Next, you want to look at the secondary check valve, the defueling valve, and the receptacle. You want to make sure that they are installed and secure, and you want to leak check the valve and the defueling valve and the receptacle and all the connections, also to make sure those are not leaking. 2 primary types of cylinder mounting. You see what we call a belly mount cylinder. On the left-hand side, these you can see the straps that are holding that cylinder in place that go around the longitudinal area of the cylinder. So that is a belly mounted cylinder. The cylinders on the right are what we see in transit buses and also heavy duty tractors. They are neck mounted. So they're mounted at the neck of the cylinder and not at the belly. So for the belly mounted cylinder, step 3 includes, and it's a very important part of the inspection, to make sure that the mounting brackets and the straps are clean and that they're in good condition, they're not corroded, and that they're firmly restraining the cylinder. Cylinders move a little bit, and they're supposed to move a little bit, but there is a specification in NFPA 52 that defines how much they're supposed to be allowed to move. You also want to check the brackets for any signs of stress or corrosion, the proper tightness, make sure the securing bolts are there, and the condition of the rubber pads, and I'll show you some rubber pad issues a little bit later. Next, you move on to the cylinders. Now, we got 4 bullets here about inspecting the cylinders. First of all, you need to make sure that the label is affixed and intact. As a matter of fact, if a cylinder doesn't have a label and you can't find a label for it, that cylinder has to be condemned until you can either get a label or it has to be condemned, period, because you cannot operate a vehicle with a cylinder that has no label. You want to verify that the service pressure of the cylinder does not exceed the vehicle service pressure. This is a requirement of NFPA 52. And then you want to verify that it has not exceeded the marked service life. There is an expiration date on all the cylinders. You can see on the label at the top, the expiration, it says do not use after January of 2034. So you want to make sure it's not later than January of 2034. And then finally, you want to be able to identify any damage to the cylinders, and you have to assess the type of damage, which we call classifying the damage, as well as the level of damage. Now that process of assessing cylinder damage is a very detailed process, and it requires some detailed training that we're not going to go into here today on how to identify the types of damage how to perform the specific measurements, and then how to use the manufacturer's guidelines in order to determine the levels of damage. When we speak of levels of damage, there are 3 different levels, and these are uniform across the industry. Level 1 is either no damage, or there is an amount of damage that when you measure it is acceptable according to the manufacturer's guidelines, and repair is not required, and therefore you can return that cylinder to service. Level 2 is damage that might require repair, or it might require more evaluation, or it might require that the cylinder be condemned. It has to be further investigated, and the manufacturer's guidelines is what determines that. And then finally, level 3 damage is damage that is severe enough that the cylinder cannot be repaired and must be condemned. So from a practical standpoint, when you're assessing cylinder damage, you're looking for any visual evidence of a cut, a scratch, a gouge, an abrasion, heat damage, chemical attack, etc. And you are measuring depth, width, and length. The most severe damage element is depth. So take a look in this slide. You've got the cylinder damage levels for cylinders that are manufactured by Agility Fuel Solutions. Now you'll see they break level 2 damage into 2A and to 2B. But what I want to point out here is the tiny level of depth of an injury or damage that can even cause a cylinder to be condemnable. So level 1 damage, if you find a cut, a scratch, a gouge that meets the length and length requirements and is less than 10 thousandths of an inch, then you're good to go. If you range anywhere from 11 thousandths to 50 thousandths of an inch, that's level 2. And for Agility cylinders, they can either be reworked in the field, or they have to be removed from the vehicle, sent back to the factory and reworked. Any damage that is greater than 5.05 or 50 thousandths of an inch where there is damage has to be condemned. Okay, that's not much depth. The next step, we look at the pressure relief devices and the vent lines. We have to verify that there is at least one PRD attached to every cylinder, that the PRDs are in good condition, and that the eutectic material is still intact. It has not extruded for any reason, and that each PRD has a connected vent line. So there's a whole process that is used to do that. We inspect for damage to the vent lines and any debris blocking that outlet. And then in the bottom photo, you see those black plastic caps. Those are vent caps. And everybody thinks they're just cute. No, they're not just cute. They're there. They perform several functions. They keep debris and water out of the vent lines, because if you get water in a vent line and you're operating in a really cold climate and it freezes and then there's an incident, there's going to be a problem. But also, if there is a missing vent cap, it might mean that the PRD has activated, that something has happened to cause that PRD to activate, which would be a thermal event, and that needs to be checked out as well. And of course, you need to perform a leak check between all the interfaces of those components. The next components are the fuel system isolation valve, high pressure coalescing filter, fuel shutoff solenoid, and the high pressure fuel gauge. All of those need to be visualized, manually touched, shaken, moved, attempted to move to make sure that they're installed securely and that they're not damaged, and then leak checked as well. And then step 7 is the pressure regulator. You have to make sure that it is installed and secured, that it has a PRD or a PRRD, which is a pressure relief, a pressure resettable relief device. Those, you have to make sure those are there and that they're secure. Leak check it, of course, and then you have to verify that the coolant lines are connected and not leaking coolant. And then finally, based on all the findings of the inspection, you need to identify and determine whether, based on those levels of any levels of disrepair or damage that is found, does this fuel system pass inspection or does it fail inspection? All right, I'm going to show you some photos, but before I do, here's a question. How frequently do you think CNG fuel system inspectors find safety issues that need to be resolved?
I also have a question in line for you, Annalloyd, when you're done with the poll.
Okay, perfect. Okay, good students, very good students. Frequently, 50% of you said frequently, 42% said occasionally, 8% said rarely. So we're going to talk a little bit about that, and I'll show you some of the common findings, but let me pause to answer the question that we have.
This question came from Gilbert Castro, and I thought it would be a better idea for you to just share it with everyone than me type back to Gilbert. His question is regarding the cylinder expiration date.
Yes.
The last day of the month, for example, expiration 12/20 would be good until the last day of December or the first day of the month?
I would say the last day of the month. I don't think there's that specific, but you don't want to use it beyond the last day of that month.
Perfect.
Any other questions?
Not at this time.
All right. So let me show you some of the things that we see. So our trainers are out about 40 weeks a year. We deliver right now, we're training about, I would say about 75 classes for 75 different customers of classes during the year. And so we see all kinds of fuel system installations. And one of our, when we do our live training, it includes hands-on labs. And one of the hands-on exercises is you take the inspection form at the end of the class and you go out and you perform a fuel system inspection. And we're always amazed at what we see. So often we see things like this. There is inadequate clearance there. NFPA 52 defines minimum clearance between a cylinder and any other component, because as that vehicle is going down the road, any vibration that would cause that stainless steel fuel line to rub on that cylinder is going to create a problem. So we see inadequate clearances. This is another example of an inadequate clearance. This is a fuel line that is rubbing on a truck frame rail. Loose bolts are relatively common. Those need to be addressed. This is an interesting one. Someone thought it would be a great idea to put a zip tie on a fuel line, a flexible hose fuel line, so you can see it's cut right into that fuel line. That is an accident waiting to happen. We also see abraded fuel lines from time to time. This is not acceptable. This would not pass inspection. A bulging fuel line, I'm not sure what would cause that, but when you see that, you know something has happened to deteriorate the quality of that fuel line. Vent line, this is a vent line. I don't know if you can tell this or not, but vent lines are required by NFPA 52 to be vented up and away from the vehicle, because for those of you who remember, natural gas is lighter than air, so it rises when it leaks. If natural gas rose when it leaked, or if the PRD went activated, the gas would collect up under that vehicle. So that is an inappropriate installation of the vent line. Corrosion, relatively common that we see. This is an example of an over-tightened cylinder mounting gasket. So the big picture is a broader view, and then the circle gives you a cutout. And you can see that the gasket is rising up. It's not laying flush on the surface of the cylinder. And so that means that the gasket and the connections have been over-tightened. This is very common, damaged O-ring inside the fuel receptacle. If the O-ring is damaged, that creates an unsafe fueling condition. That is a I don't know, 59-cent part. I'm making it up, but those are very easy to replace. A lot of drivers just carry those with them. Missing vent cap, we talked about that earlier, about it's not just about the fact that the cap is missing, it's about the fact that perhaps the reason the cap is missing is because the PRD has activated due to a thermal event, so you definitely want to check that out. And then here's a damaged manual cylinder valve. It'd be a little difficult to shut the fuel supply off to that cylinder using that valve. This is what a leak looks like with leak check solution, obviously. Damaged shields. This is a very critical thing. If you are operating a truck or a trans bus or a refuse truck or whatever that has shields, big areas of shields, if there is damage to the shields, this may or may not mean that the cylinders have been damaged. And a damaged shield should always, always, always trigger a detailed visual inspection. This vehicle should not be driven until the cylinders have been inspected and the rest of the fuel system to make sure they're working properly in proper condition. This is a saddle mount cylinder that has a dent in it. That definitely would not pass inspection without checking out the rest of the fuel system and the cylinder inside there. And then there's another example of cylinder shield damage. Let's talk a little bit about some common types of cylinder damage. This is a cut in a type 3 cylinder, so that's what a cut looks like. That's why you need the cylinders to be clean. That's why you need relatively clean. I don't mean spotless, but you need them to be clean enough to be able to visualize, and that's why you need to be able to visualize 360 degrees around every cylinder. This is more common than I would love to see it in our industry. This is an image of a cylinder. The black surface area is a cylinder, and the green surface area is the cylinder shield. This is a refuse truck. And there was not proper clearance between the bolts and the cylinder shield and the cylinder. And so the damage there, the depth of those gouges is about 3/16 of an inch, way, way, way above the level 3 damage. This is a 1-year-old roll-off truck for one of our Republic Services clients, so a truck that's been in service just a year. And this is level 3 damage that we found to that cylinder due to the bolts. Again, that's a gouge that's been caused by the bolt. This is also a gouge, also caused by a cylinder bolt. Here's a different type of gouge. Pretty obvious that that's damage. This is impact damage, so something hit that cylinder that caused that level of impact damage. This is abrasion. Oftentimes people don't think abrasion is a big deal. If it's deep enough, it's a big deal. And this is what surface abrasion might look like. This is heat damage. So any type of heat damage, this is what it generally looks like on a type 3 or a type 4 cylinder. Any type of heat damage automatically requires that the cylinder be condemned. It is a class 3, level 3 damage, and it automatically requires that the cylinder is condemned and either removed from the fuel system or at least isolated from the fuel system. This is what chemical attack looks like, kind of a weird looking little pattern there, but this also is automatic. Level 3 damage must be condemned. I should have given us a poll question for this one. So this is not damage, believe it or not. This is what is considered to be a non-structural anomaly, and it is an acceptable level of variation in the outer winding of a cylinder. So I think if you were an average person and you looked at that, you'd go, wow, there's something wrong with that cylinder, but there is not. That is a non-structural anomaly. So just to recap, fuel system inspectors can't emphasize enough the value, the importance, the criticalness of training, and also the responsibility that a fuel system inspector carries. Not that the fuel system inspector doesn't have other resources, because of course you do. You can always call the fuel system manufacturer, the cylinder manufacturer. You can get other resources, but you need to really be able to do your job and do your job well. Sabrina, any questions you want to throw at me?
There are no questions.
All right. I'd like to talk just real briefly then about our training and certification for CNG fuel system inspectors. We are probably most well known for our CNG fuel system inspector training course. It is we used to call it 2-day, now we call it 12 hours if it's virtually, training class, and it has 2 overall objectives. Is to provide both necessary knowledge and the skills that prepares the technician to perform a CNG fuel system inspection, a thorough one, an adequate one, and that complies with all the codes and standards and best practices. And it also will help prepare a technician to sit for CNG fuel system inspector certification exam. This is a course outline of our training course. It starts out with an overview. The first 4 modules are kind of an overview of codes and standards, just the basic fundamentals of what they are and what they do, because we talk about the details of each code as it applies to each component. So the blue highlighted subjects are overview material, talk about the codes and standards components, and then we move right into a separate module for each component. Each one of those components that was illustrated on the drawing that I showed you earlier is covered here. There's a module dedicated to here's what it looks like, here's where it should be installed, here's its most common failure mode, here's how you recognize damage, here's how you leak check it, here's how to determine whether it passes inspection or not. And so that applies from the fuel receptacle all the way down to labeling, because labeling is also a requirement. NFPA 52 has very specific labeling requirements, not just for cylinders, but for other components and other areas of the vehicle. So our training covers off on all the details about how to inspect for and make sure that each of those components is in compliance and good repair and not leaking. And then the last 3 modules talk specifically about how to determine the final disposition of a CNG fuel system. How do you dispose of? What is the proper methodology for disposing of a cylinder? If you have a level 3 damaged cylinder that needs to be removed from a vehicle, how do you dispose of it? And if there's a whole procedure for that. If you don't know what you're doing, there can be serious injury. I don't mean to say that as a threat, but you have to make sure the cylinder is depressurized, and you have to be able to confirm that it's depressurized, and then you need to be able to remove the valve and the PRD, and then you drill holes in it before it's disposed of so that it can't be used again. Training also covers defueling, because anytime you're inspecting a fuel system, if you find level 2 or level 3 damage, one of the very first things, actually the very first thing you need to do is to defuel that cylinder. So it's important that the fuel system inspector know how to do that. And then an entire hands-on workshop where learners get to go out on the vehicles and actually conduct activities. Now with our virtual training, let me just back up here for a minute. Our virtual training, we have created activities that mimic the live activities that we normally would do in our live training. So we handle it that way. I want to talk a little bit about certification for a moment. We talked earlier about how the fuel system inspectors need measurable levels of knowledge and measurable levels of skill. The only way that you can properly do that is to test to it. And so we created an assessment, a test of both knowledge and the application of skills, not based on random information, not based on our training content, but based on our job study. And our certification program was created totally independently of training. It's administered totally independently of our training, and it's overseen by an independent advisory board. The members of that advisory board include cylinder manufacturers, fuel system manufacturers, vehicle manufacturers, and end users. Our certification is valid for 5 years, and what it consists of is a 60-question exam that you must score 80% on to pass. If you score at least 80%, then you are a certified, NGVi certified CNG fuel system inspector. We give each learner each test taker 2 opportunities to pass. Some people just don't love tests, don't get a little nervous before a test, so we have 2 opportunities to pass, and we offer that certification exam live or online. So if we're delivering training for you live, you can sit for the inspector certification exam right there, and if not, it can be taken online. Real quickly then, I've pointed to training. I'd like to just highlight our live virtual training schedule. We have taken our fuel system inspector training. We spent 4 weeks, 4 complete weeks, and we have completely modified it so that it's not just a bunch of slides thrown up on a screen, but it's actually interactive CNG fuel system inspector training. It follows the same curriculum outline. It's the exact same content, but we have made it interactive to make sure that learners are learning, that technicians are learning. We're offering it 3 times virtually through the end of the year. We'll be offering it again next year, but September, October, November, it's all on our website, and you can sign up for that. If you prefer not to do live virtual training, so live virtual training, you will sit in a virtual classroom with one of our trainers. You will ask questions, you will be asked questions, you will have opportunities to engage with the trainer, etc. And if that's your preferred learning mode, great. If you prefer to take fuel system inspector training online, completely online and on demand, we have that available whenever you would like to take it. This, just to show you how to find it on our website. This is a screenshot of our website. You can see the September 16, 17 registration button is circled. You click there and it takes you to the registration process. If you want to register for e-learning, this is where you do it. You click there. And then when you get to our registration page, we're offering a 10% year-round discount for anybody who's a member of or participates in or just sat in on this Clean Cities webinar today, but any Clean Cities member across the United States, 10% discount. You have to enter that discount code that's in the circled box in order to get that code applied to your checkout. I believe that's all I got. I'm going to turn it then back to Tim and Edgar and say thank you everyone for participating. We appreciate you being with us today.
Thank you so much, Annalloyd. I really appreciate it. That was really fantastic. And just to sort of wrap things up here, I wanted to go back and share this information with folks. And thanks to everybody for attending. We really appreciate it. I wanted to let everybody know we have the upcoming webinars. Yes, we will thank everybody once again for joining us. We look forward to seeing you on our next Tech and Spec webinar, and we'll call it quits for now. Thank you all very much. Thanks again, Annalloyd, and thank everybody for being with us today.